Designing and Sizing of a High Solids Anaerobic Digester by Danielle Boucher, Daniela Serna, William Westerfield, Shadi Yusuf, and Carson Zayed. Our goal is to design an industrial-scale reactor that will convert yard waste to biogas using a CSTR reactor with methanogens. We designed the reactor to be able to process 1,000 dry tons of waste a year. We then determined the volume of the CSTR and retention time. These are the design equations used to determine the volume, rate of reaction, and retention time. In order to find the rate of reaction, we must obtain our rate constant K from the literature. Ngozi, Abli, and al. Reported their rate constant of K equal to 0.15 from the Arrhenius equation by plotting the experimental data. Lee and al. Reported a rate constant of K equal to 0.12. We took the arithmetic mean of the two K values and ended up with a K value of 0.135. In addition to determining the rate constant, we also determined from these two that the rate of reaction was reported as elementary and a first order by both these sources. We assumed that the conversion was 52%. The experimental data on conversion of biomass to biogas conversions ranges from 40 to 65%, taking the arithmetic mean to assume the conversion is 52%. These are the desired reactions and intermediate steps. We assume the input becomes the output, and the reaction is considered feed plus water goes to methane plus carbon dioxide, water, hydrogen sulfide, and NH3. The undesired side reactions are shown below. However, it is assumed that the presence of side reactions is negligible because their optimal temperature range is 140 degrees Celsius to 165 degrees Celsius. To determine the balanced chemical reactions and chemical equation of the feed, the Booswell and Mueller equation was used, shown below. The parameters A, B, C, D, and E were determined by using the percent weight obtained from the ultimate and proximate analysis of the feed. Determining the mass balance of the feed. Total digester feed is equal to dry feed over percent solid, whereas wet feed is equal to dry feed over 1 minus percent moisture. The moisture in the feed is equal to wet feed minus dry feed. The water added is equal to total digester feed minus wet feed. The outputs are biogas, determined from the balanced Booswell and Mueller equation, solid digestate, unreacted matter and fixed carbon, and liquid digestate, water not used during the reaction. The energy balance, determined by the Dulong equation, is shown below. Energy of the biogas estimated as energy content in methane, heating value of methane equal to 52 millijoules per kilogram. The energy of methane is equal to the heating value times the mass flow rate of methane. We want to find the volume of the CSTR and retention time for the volumetric flow rate of 1,000 dry ton of yard waste per year. The design equation for calculating the volume in the previous slide can be manipulated using the equations shown since we did not have an initial concentration. The volume equation is manipulated so that we do not need to use the initial concentration. The resulting volume of the reactor is 232 meters cubed and a retention time of 16 days. The common reaction parameters used are a temperature range of 50 to 60 degrees Celsius. The higher temperature will increase the rate of reaction. The conversion of biogas will increase along with the rate of the reaction. Methanogens are inhibited at a temperature higher than 70 degrees Celsius. Methanogens are used in anaerobic digestion to produce methane and carbon dioxide. These contain a variety of coenzymes that make them immune to antibiotics. They can utilize simple energy for conversion. Methanogens deactivate at high temperatures. When dealing with anaerobic digesters, there needs to be a caution to avoid drowning and falling into the digester. Ropes and ladders need to be readily available for rescue. There is also an additional risk of falling off the digester. A person can be burnt by the exhaust gas from the digester. Caution also needs to be taken to avoid feed spills that could cause a biological hazard for the people in the plant. Biogas generated from the anaerobic digester is also flammable.